Hello. One other topic we want to talk about this week, and it was the final piece of the design checklist that you were given last week in regards to how to build a program, design a program, and then build a program. And if you remember, we have now walked through everything. Now we got the scope. Our last two pieces were create test cases and test our logic. And I want to talk about that a little bit, and that's what this video is all about. It is about testing our logic. This is something that we will build on as we go through the course, but let's get started right now. So it'll be kind of overly simplistic at this point in time, but still very important, okay? So it's very important to pay attention to this. All right, objectives. Why do we need to test our logic and programs? And finally, we'll talk about how do we test our logic. I'm going to go back and talk about a little story of mine. Sorry, I have a lot of stories. Probably that's why I became a teacher, so I can convey my stories to you so you don't make the same mistakes. One of my stories is one of my first jobs. Right out of college, I had a bachelor's degree in computer science. I worked for a place called Midwestern Indemnities. They were over in Milford, Ohio. I don't think they're there anymore. Probably because I worked there. Who knows? And I was given a project to do, and I wrote this project, and I was very proud of the project, matter of fact. Got the project done, and I gave it off to my user. My user, I think, worked in the marketing department or whatever, and they were the ones paying me. And so I sent it up there, and I said, hey, here it is. It's all finished. If you want to test this, go at it. And so they tested it, and next thing I know, she's walking back down to my office. She was on a different floor, came down to my office and said, Bob, this doesn't work. I go, oh, what do you mean? Well, she says, well, I did this and I did this. And I went, oh, okay. And I'm like, why did you do that? And she goes, well, because I could. And I'm like, okay. And so I go in and I fix it. And I went, oh, okay, I see what the problem is. Yeah, I didn't really look at that too hard. And next thing I know, I gave it back to her. She came down, not that much time later, I don't know, 15 minutes, half hour later, saying, all right, Bob, it still doesn't work. You know, you're getting output, but it's not working. I'm not getting the right results. And I went, what? And so I did this and fixed that and sent it back to her. And I thought, okay, it's working now. It's all good now. Here. And she came back down and said, nope, still doesn't work. Well, next thing I know, I've lost credibility with this lady. She was a very nice lady, but I lost credibility with her as a professional developer because I'm sending her things that, though there was output, it didn't work. And next thing I know, my bosses are looking at me like, what are you doing? Do you know what you're doing? And what was interesting was it wasn't a lack of effort, and it wasn't laziness, it wasn't anything like that. I truly had no idea how to test a program. I was never taught that in college. And so, fortunately, how the story ends, AT&T called me up and says, hey, you want a job with us? And I said, yeah, get me out of here. They don't really like me anymore, even though I really enjoyed working over there. And I got better, but I wanted to go work at AT&T, and AT&T gave me the opportunity to learn how to do things really right. And we spent several weeks learning how to test our programs completely, and I was shocked by what I learned in that. For the most part, shocked in the fact of how simplistic it was to ensure that your programs are always right. And two, shocked that there was such a methodology out there, and shocked I didn't learn any of that in college. I don't want you guys to go through that. Okay, I want you guys to learn how to test and make sure that your output is good and it's always correct. All right, so I'm going to show you how to do that throughout this course, and hopefully you keep doing this throughout your career. All right, so let's get started here. So basically, though it's always exciting, like I said, I know as a new programmer, when you get to the first couple of weeks and you press a button and you get output, it's very exciting. You got a program working. And I see people's faces light up. Oh my God, I got it to work. This is fantastic. So it's kind of cool that somehow you put in input and you press the button and you got output. But the question I always have, and sometimes it's always kind of funny, is it correct? And usually students look at me and go, well, what do you mean is it correct? Well, I got output. No. Is it correct? Is whatever you're supposed to do correct? Right? Last week you were supposed to figure out the radius, right? I'm sorry, the area based upon the radius. And when you pressed the button, you got output. Did you check to see if it was correct or not? That it was 100, and it actually added up. Maybe some of you did, some of you didn't. Or were you just happy you got output and said, I'm done, send this thing up. And if you did, that's pretty cool right now too. But we don't want to write a program for somebody who really needed those numbers, and they needed them correct numbers. Maybe they were building something or whatever, and if our program didn't do it right, we got nothing. They have nothing. Next thing you know, they're building things incorrectly, okay? And so we need to make sure it's correct. So a program that provides the wrong answer is just as worthless as a program that doesn't work at all, meaning you don't get any output. Getting output that's incorrect, you might as well not have any output. It's worthless, okay? We cannot hand programs over. We do not get paid to write programs that are wrong, that our output is wrong. So for example, imagine you write a program that takes two pieces of input, adds them together, and displays the result, right? And you write the program, you run the program, you put a 5 in one box, text box, a 10 in another text box, but your output shows 13. Well, you got output, okay? And like I said, as a beginner programmer, sometimes that's just as exciting and you're ready to hand it in right then and there. But is it correct? And in this case, it's not correct, right? So we all know 10 plus 5 equals 15. At least I hope you know that. And so it's incorrect. And so what do? We say, well, we're done. I don't know. I got output. No, we get to make sure output is right, okay? So because the output is wrong, the program is wrong. This program is worthless, all right? I actually had an opportunity to work at a place called Paycor. You probably heard of it. And we now have a Paycor Stadium, correct? And so with that said, I remember I worked there, and we were actually writing the software for their payroll program that they actually lease to people, or people buy payroll from them. And we were getting wrong answers on the paychecks. Guess how many clients really like that? So their clients, all of a sudden, they hired Paycor to do their payroll for them. And then when we handed them the checks, they were incorrect. That's not cool, right? And so imagine you're expecting a check for $1,000, you get a check for $10. Well, it's output. No, it's the wrong output. All right, you get the message? So the moral of the story is your program not only needs to display the output needs to be 100% correct. There can't be any exceptions to that. All right, I know I've always heard this 80-20 rule thrown out here and there. Oh, if it works 80% of the time, we're good. I don't like that. I was taught differently. Fortunately, at AT&T, not my college, but at AT&T, that said, yeah, it needs to work, and it needs to work right 100% of the time, or we're not going to be too happy about it. So how do we test our logic? To properly explain, let's look at an example, okay? So let's go look at, let's see, I'm going to pull up one of the ones we did before. Let's see here. Let's do this one. Okay, remember this? We did this last week when we were actually adding three numbers together in our videos. And so we sit back and we kind of look at this, and we sit back and we say, okay, how do we test this program? Well, there's three pieces to testing, okay? And the three pieces are, you got to identify all the paths, then you create a test case, and then you ensure that every path is tested based upon the multiple test cases, all right? So the first question is, and then, I'm sorry, there's one more step. You identify all the paths, you create a test case, and you also create in that test case, okay, a test case consists of inputs and the expected results from those outputs. So to properly test, you need to actually do the calculations manually yourself, to knowing what the answers should be, okay? So let's go walk through this one more time. We sit back and we talk about paths. P-A-T-H-S is what I'm saying. Paths. A path, like a path in a road, or a path if we're taking a walk, we're going down a path, and so on. How many paths are there in this particular algorithm right here when we get the number? So I don't know what you're all saying out there. I always end that like I'm expecting you to scream it out to me, but I hope you are. There's one, okay? We start at the top and we go down. And you might be saying to yourself, okay, so when do we not have more than one? When we get to conditional programming. that's when we have multiple paths, okay? Meaning we'll start asking questions, and based upon the answers of the questions, we'll take different paths based upon those answers. We're not there yet, so we'll actually address that when we get to that point. Right now, we're dealing with the sequential structure, which is top down and literally has one path. So good for us. It's just one path right now, so pretty simple. You're going to write programs here in a few weeks that will have, I don't know, 15, 20, 30 paths. And we just need to make sure we test each one of those paths. And again, we'll explain it at that point in time what we're talking about. But this has one path, so we don't need to do too much. We just need one test case to do it. What do I mean by that? Well, what we need to do is we need to create a test case. And what a test case is, actually putting numbers to these variables. And then, based upon what we know should happen, determine what the expected results should be. So I actually created one right here. Okay, I don't know where that came from. Let me get rid of that. And so in this, I should not got rid of that. What am I doing? Okay, there you go. I have a number, 10, 5, and 3, and my sum total, my expected results, if I say 10 plus 5 plus 3 equals 18. I'm not looking at my program right now. I just know that I've added those together. My product total is 10 times 5, okay? So 10 times 5 is 50, times 3 would be 150. These are what's called my expected results. Doesn't take very long to create a test case, okay? But the expected results are what you need to know. Then what you do is you go up to your logic and you walk through it step by step. There are times where it's kind of hard to walk through your own logic because you wrote it the way you understand it. Sometimes you might need to take this logic, meaning this algorithm right here, and give it to somebody. Give it to your friend, parents, I don't know, partners, whatever, and you know to look at and actually follow your directions. That's what this algorithm should do, based upon this input, and see if they get the expected results. Does that make sense? If you can remove yourself from it, meaning you're just going to read what's sitting there, you might be okay. Mine says go get number 1, 2, and 3. Okay, got it. I'm going to say sum total, okay, equals number 1 plus number 2 plus number 3. Got it, got it, got it. So 15, 18, yep, that's what I expected. Cool. Product total, you get the idea. 1 times 2 times 3. And then I am good to go. And in this case here, I expected it to be, so 1 times 2 is 150. I'm sorry, yeah, no, 50. 1 times 2, 10 times 5 is 50. There you go, times 3 is 150. And now that's what I expected. Now I know my logic works. Pretty simple, right? I know right now it is. As I told you before, let's start simple, because when things get more complex, you'll know the process is actually making sure you can test it. Testing doesn't have to be hard. And most of the time, if you just follow what I'm telling you here, you'll ensure that your program is always right. But if you don't take the time to actually create a little test case and create those expected results, you never know if you got it right or wrong, correct? The next step we would do after this is that we would go write our program. Now that we have all this done from the design checklist, we have all this written down now, we would go write our program. Okay, so we write our program the way I taught you how to write your programs, taking this design and applying it to the programming language. And then guess what we do when we get done with that? We use this exact test data to test our programs. Okay, and so by doing that, and if we put 10, 5, and 3 in our inputs and we get these answers, we know everything works perfectly. I don't have to test anymore. It's not going to change. You can, but you don't have to. But if I put these 3 things in there, we know my logic works, okay? So if I put these 3 pieces of input and I get different answers, we know my logic works, but we know our program doesn't. So our problem is not with our logic. Our problem would be with the program itself. Somehow we did something wrong in that program, and we can go find that issue and fix it. But if you run the program without this test case, you put 3 things in, or you put for better purposes, if you put a radius in, and your output comes out, but you never really looked at it to determine what it should be, you don't know if you're right or wrong, correct? And that's what test cases are all about. All right, let's go back to here and finish this up here. I think the rest of my stuff, the testing methodology can be a course in itself. And so in this case here, the testing methodologies can be a course in itself. It can be. I spent about 4 or 5 weeks at AT&T learning how the different testing methodologies. What I'm teaching you right here will take care of 99.99% of most things. Yeah, I know I said 100% before. There is that 0.01 out there that we're not covering, or we may not be covering, I should say. That can get really deep, and I'm not going to go that deep into this case. If I can get you to test it and it works 99.99% of the time, you're doing fine, okay? And so that's kind of what we just covered there. In this regard here, where we sit back once again. We identify all our paths. We create a test case that includes our inputs, our expected results, and the paths tested. And again, in our case, we had one path, so we tested path 1. And this will grow and grow as this course continues. Okay? So anyway, a little thing about testing. It should not take you very long to create test cases and test your logic, and then use those test cases to test your program. I hope this makes sense.